In this video, we're going to start solving some equations that contain radicals. So here we're asked to solve the equation, the square root of x plus 3 equals 4. The very first step to solving any equation that contains a radical in it is to isolate the radical on one side of the equation. In this equation, we see that our radical is already isolated because it is the only term on the left side of our equation. Once we have the radical term isolated, the next step is to undo the radical. Well, what operation do we know that will undo a radical? Another way to say that is, what is the opposite of taking the square root of something? The opposite of taking the square root is squaring. So whenever we're solving a radical equation that contains a square root, we want to get that square root by itself first and then square both sides of our equation. So that would give us an equation that looks like this. Notice we squared the square root on the left and squared the 4 on the right. But if you watch the previous video, you should know that this raises red flags. In the previous video, we learned that raising both sides of an equation to an even power sometimes introduces extraneous solutions. Not all the time, but sometimes. So anytime we solve an equation by raising both sides of the equation to an even exponent, we have to make a mental note and say to ourselves, when this is all said and done, I have to check my solutions. I must do that. So let's make a mental note of that right now before we go any further. Okay, so now that we got that out of the way, let's simplify both sides of our equation now. On the left, the square root of an expression squared. What happens when we square a square root? Yeah, the square root and the square are opposite operations, so they cancel each other out. So on the left, when we simplify, we're left with the expression x plus 3. And on the right, 4 squared is 16. And the resulting equation is x plus 3 equals 16. This is a linear equation, and we already know how to solve linear equations. So now we just subtract 3 from both sides of the equation to solve for x. And we find that x is equal to 13. But remember, we squared both sides of the equation to solve it. So x equals 13 might be an extraneous solution. We have to check. So in our original equation, everywhere we see an x, we're going to substitute in 13. That gives us the square root of 13 plus 3 on the left, and 13 plus 3 is 16, and the principal square root of 16 is 4. So we have 4 equals 4. That checks. So that means that x equals 13 is the solution to this equation. Let's take a look at this example. This equation is the square root of y plus 2 on the left is equal to 4 minus y on the right. This contains a radical, so the first step is to get the radical expression by itself. Well, on the left, the radical expression square root of y plus 2 is already by itself, so now we move on to the second step. The second step is to undo the square root. We undo a square root by squaring. So let's square both sides of the equation. So our equation now looks like this. But remember, we're squaring both sides of an equation, so that's a red flag. We have to check our solutions. Now this example is a little bit different than the previous example. In the previous example, on the right side of the equation, we only had a single term of 4. In this example, on the right side, we have a binomial expression, 4 minus y. So when we square the right side of this equation, we'll be squaring the binomial 4 minus y. So that means we'll have to FOIL 4 minus y times 4 minus y, like this. Now let's look at the left side of our equation and simplify it. When we square a square root, the square and the square root cancel out, leaving us with y plus 2 on the left. Now let's FOIL 4 minus y times 4 minus y on the right. That gives us 16 minus 8y plus y squared on the right. Notice now that this equation is no longer a radical equation. It's a quadratic equation because the highest exponent we see on our variable is a 2. We know how to solve quadratic equations by factoring. So let's rearrange this equation so that all of our terms are on one side and it's set equal to 0 on the other side so that we can factor to solve. Subtracting y from both sides gives us 2 equals 16 minus 9y plus y squared. And subtracting 2 from both sides gives us 0 equals 14 minus 9y plus y squared. Now I'm going to rearrange my terms on the right side of the equation so that they are in decreasing order of exponents. In other words, I'm going to put my y squared term first, my minus 9y term second, and my 14 term last. Now my terms are in the correct order so that I can factor y squared minus 9y plus 14 to solve my equation. Factoring the right side of the equation gives us the factor y minus 7 times the factor y minus 2. Setting each of those factors equal to 0 and solving for y gives us the possible solutions of y equals 7 and y equals 2. But because we squared both sides of this equation to get those possible solutions, we may have an imposter, or both of them may be imposters. The only way for us to know is to check our solutions. Let's check y equals 7 first. Substituting in 7 everywhere we see y in the original equation gives us the square root of 7 plus 2 on the left should be equal to 4 minus 7 on the right. The square root of 7 plus 2 on the left gives us the square root of 9, and 4 minus 7 on the right gives us negative 3. Now on the left side of this equation, we need the principal square root of 9. In other words, we're looking for the positive square root of 9 only, and that gives us 3. And that's equal to negative 3 on the right. That is a false statement. That tells me that y equals 7 is an extraneous solution. It's not a solution to this equation at all. So we mark it out and toss it to the side. Now let's check y equals 2. That gives us the square root of 2 plus 2 on the left and 4 minus 2 on the right. Simplifying both sides gives us the square root of 4 on the left equals 2 on the right. Now remember, on the left, square root of 4 means the principal root of 4, or the positive root of 4. The positive square root of 4 is 2. So we have 2 equals 2. That's a true statement. So that tells us that y equals 2 is a good solution. And in this case, is the only solution to our original equation. So therefore, this equation has one solution, y equals 2.